Hi everyone, let's continue with our Line 75 coding series. So today we are going to solve product of array except self code problem. So let's go through the problem statement. Given an integer array nums, we need to return an array answer such that answer I is equals to product of all the elements of nums except nums I. Let's try to understand this line. So here, for example, let's say like for this index I am trying to calculate the answers except this element, whatever total elements we have in this nums, we need to do the product and that would be the answer for this index. For example, the other elements are 1 2 and 4. We are just doing the product, we are getting, and that is the corresponding answer for this index. Same applies for this index, last index. For 4, the remaining elements are 1 2 and 3. We'll just do the multiplication. We got 6 and 6 is the answer. Okay, so this 6 is the product of all the nums except nums I. Okay, now when we ever we are doing the product for any prefix or suffix of nums I, it is guaranteed to fit in 32-bit integer. So definitely, let's say like this we what we have to do for this index, we need to do the calculation of all the element except that one. So definitely while doing the product, it could be a case like it can go out of bound of this 32-bit integer. For example, let's say like I have numbers like 10 to the power 6, 10 to the power 6, and 10 to the power 6 and 4. Okay, so for this one, like we have to multiply all these numbers, so it would become 10 to the power 18. That is beyond the range of this 32-bit integer. Plus 32-bit simply can go 2 to the power 32 minus 1. Okay, and here if you choose to the basic calculation, it would hardly go 10 to the power 8. Okay, so it is always guaranteed. So we don't need to worry about that one. We have to write our algorithm in that would take order of n time, and we don't have to use the division operation. Okay, let's first try to understand like if we don't have this constraint with us, so we don't have to use the division operation. Then how can we solve this problem? Let's try to use. So let's say like I just have this one, two, three, four, and let's say like I can use. It is allowed to use division operation. Then what we can do? Like our algorithm steps would be step one. Iterate the array and do the multiplication of all the numbers and store it in some variable. Okay, calculate the product of all numbers and store it in a variable. So let's say like I name it product. Okay, so for our example, it would become 1 into 2 into 3 into 4, that is 24. Okay, now step 2 would be iterate through the matrix, iterate through the array, and for each individual element, do product by numsci, and you will get the result. Okay, for example, we have original input as 1 2 3 4, that is nums. Product we know, that is 24. Okay, so answer would be 24 by 1, 24, 24 by 2, 12, 24 by 3, 8, and 24 by 4, 6. And this is the final answer. Okay, so here we just have two steps. Let's calculate the time and space complexity. So we are having time complexity order of n and space complexity order of 1. Okay, So we are just going to modify the existing array to store the result and return the result. Okay, but this is not an acceptable solution. So we should not use we should not use division operation now. So the earlier solution that we have discussed where it is allowed to use the division operator. Okay. Now we don't have to use the division operator. Then how can we solve this? So here we need two constraint division not allowed and expected time complexity is order of n. Okay. Now let's try to build our solution considering both the case. So this is just a division operator. This I am just representing this as a division operator. Okay. Now let's try to come up with an approach. So here the expected time complexity is order of n, but there is no constraint on this space. So using some extra space, can we solve it by having all the constraints in place like division operator not allowed and the time complexity is order of n. Okay. So let's try to utilize extra space to solve this problem. So this is the original array. Okay, let's name it original. Now what we can do, we perform left product. Okay, that I'm just calling it left. So left product, what it will store. So for any index, let's say like for this index I am processing. So excluding this element, whatever is the product of the remaining left element. Okay, it will store. So for this example, it will store 1 into 2, that is 2. Okay, at this place. Similarly, for this index, what it will store all the product of all the element that is in the left hand side. So in the left hand side, we have only one. Okay, and for this one, the default one is one. Okay, because for this one, like in the left hand side, we don't have any value. Okay, so for this 4, like we have this 3 into 2 into 1, but up to this excluding this 3, we have already stored the value. So including this 3, what we could have 6. That you can also validate 3 into 2 into 1, that is 6. So similarly, we'll calculate the right product. So right product at any index will store all the element. Let me just do it quickly now. Right product for any element or for any index, it will store all the product product of all the element excluding the current element. So for this, it will just store 4 because it has only one element 4 excluding that element in the right hand side. So it will just store 4. For 4, we don't have any element on the right hand side, so it would be 1. For 2, we see two elements are there, 3 and 4. Okay, so we should store the product of 3 into 4. But if we see like for this 4, like we already stored the value as 4, like but if we include this 3 also, then it would become 12. Similarly for 1, so for up to this element, we have already stored the value as 12. So we just include this one, 2, 12 into 2, 24, and this is the final right product. So now we have for any index, let's say I. So in left is containing all the product. Left is containing the product of all the elements in the left hand direction, and right is containing all the product of all the elements in the right hand direction. Okay, and if we just multiply these two things, then we will get the product of all the nums except nums I. So that is our purpose. So if you just multiply these two things, and let's say like in answer array, I'm storing the result 24, 12, 28 into 6. Okay, and this is the final answer. So let's discuss about the time and space complexity. So let's do the actual calculation here. So if you see like you're iterating the original array to first create this one and this one and this one. Okay, so we can say it's 3 into n, and that is order of n only. For space, if you see, although for the answer like you can utilize of the existing array among all anyone you can utilize to store the result and return the result. but at least you would require this left and right to store the element. So we can say 2 into n, that is order of n. Okay. Now the problem here, can we try to optimize the space complexity instead of using two extra space? Can we do it in a single space? Let's try to think. So this right at any point of index, what it is storing? Product of all the nums except that current index, and these nums are residing in the right hand side. Okay. So can we do it without using this right space? Sure, we can try to think and try to come up with an optimal approach. So let's say, let me just write down the original input, and left and right. Left is just like 1, 1, 2, 6, and for right. Let's say like instead of storing it in some variable array, we are having it in this variable. So at any point of time, you see like right is just holding the multiplication of all the nums that is residing in the right hand side except at current nums. Okay. So at any point of time, it has just one state. We can say that we can populate using the multiplication logic. Considering the same scenario, it would store the product of all the nums except at current nums. Okay. Now let's try to calculate the answer. So for this right one, let's try to populate the final result in this left one only, this left array only, and we'll just return this left from our method. So for this except last element one, this one. So in the right hand side we don't have any element, so we are saying the product is one. Okay. So 6 into 1 is 6. That is expected. Now we will update the value of right, because the next element we will try to process is 3. Okay. And for this 3, the product of all the nums in the right hand side except this 3 is 4. Okay. So 1 into 4, we could have 4. So for this 3, our left is ready, our right is ready. Let's try to calculate the answer. It would become 4 into 2, 8. Now we'll update the value of this right. So it would become 4 into the element that will have just processed 3, that is 12. Now 1 into 12 is 12. Okay, so it is 12. Now we are done with the processing of this 2, so we'll just update its value 24. Okay. Now I will just multiply this 1 into 24 and we will get our result. So our result is 24, 12, 8 and 6, that is the expected output, so we'll just return this one. So the time complexity here again is order of n, and space complexity is again here order of n, but instead of using two array we have just used a single array. Okay. So that is the optimal one. So let's try to code it quickly. So I'll just go ahead and code the optimal solution. So if you want, you can implement the brute force solution also, where we are using two extra space. Okay, let's try to calculate it. Just calculating the length and storing it in its variable length. And let's say like left, I just name it of size. Its first value would be 1, because it didn't have any element to the left hand side. So the product we can assume is 1. Now from index 1 till n we need to process and store. That would be simply nums I minus 1 into left I minus 1. Okay. So for example here, let's just try to validate and ensure its correctness. So 1, 2, 3, 4. First is 1. We started with processing of this one. So for this one, the expected value is 1 only. Okay. So what we are doing, we are going names I minus 1 into this one. For this one, nums I minus 1 2 into this. So it would become 2. And for this one, nums I minus 1 is 3 into 2, 6. So yeah, our approach is working as expected, and it would calculate the left product array properly. Now for the right one, I'm just initializing it with 1. So now I just need to populate the remaining elements. Okay, the answer would be calculated in this one only. Okay, so for this one, like we already have our this is our original array 1, 1, 2, and 6. This is the left array we have. Okay, and for this right one, right was earlier 1, so we calculated its value from the right hand side. Okay, so nums I minus 2 that we have started. Okay, I equals to n minus 1, we can say I equals to n minus 1, I greater than equals to 0. So for this 6 one, like we have performed its multiplication, 6 into 1 6, we have just updated it to 6. After that, for this right, what we were doing, I n minus 1 we are having, that is this last one. Okay, and so we need to store the, we should start with I equals to n minus 2. Okay, because for this one, like it doesn't matter. Let's try to run the code to see, otherwise we'll just debug it quickly. Okay, so it is not returning us the expected output. So let's try to understand what is the issue with the code, and accordingly we can update it. Okay, so one issue that we I could see here, like let's say like we are starting with this one, and this right at any point of time it should store or multiply with numpsci directly. Okay, and after that, for the next iteration it will start consuming the latest value of this right to calculate the answer, and that would work as expected. So now our code is working for this input. So let's quickly validate it for the remaining given input. Now it is working. Let's try to submit our code. So it got accepted with 100% faster rate. So yeah, that's all I have for this problem.